to do the last examples on general motion. Yesterday, a student asked me, what if we take moment at point A? Okay. So this example was done yesterday. What I did yesterday is that I took moment at point G. Okay. I took moment at point G. We have this relationship. Now I'm going to take moment from point A. Okay. So I like you all to have that level of confidence that I do. I remember I told you guys that taking the moment from anywhere, the answer is the same. So I'm going to start with this, then I'm going to continue in yesterday's problem, okay? So we're going to take dimension moment at point A, and this will be equal to summation of moment at point A, kinetic. Okay. So we're going to take moment at point A, right? We're going to take, if we look at the forces, so now we're going to take moment at point A. I'm circling the red dot. Now, the moment of 150 Newton can be felt anywhere, okay? So it's going clockwise. So this is minus 150. Any other moments? Nope, there's no moment based on the free body diagram. So now if we take the kinetic at point A now, okay? So what we have is the equation changed slightly. Okay, so you have MAGX going in the anti-clockwise direction. So so this will be minus, sorry, anti-clockwise will be positive. AGX. And then you have to multiply by 0.75 the radius. Okay, so that is going in the anti-clockwise direction. Then you plus by your minus by your IG alpha. Okay. So we know that this problem, the mass is 30 kilogram. Then you have AGX. And then you multiply by 0.75 minus. So if we look at, so this will be equal to what? We did calculate yesterday. I think it is 1 over it's 1 over 12. The mass is 30 kilogram. The length is 1.5 squared. And then we have alpha. Okay. So we have minus 150. 30 times by 0.75 is you get 22.5. And minus by 1 over 12 times 30 times 1.5 times 1.5. You get 5 point. Oh, missing Eugene. Come on, AGX. And this is equal to, not equal, minus 5.625 alpha. And yesterday we found a relationship, right? Note that AGX is equal to, I can't remember now. So we found a relationship that AGX, can you remember? AGX is equal to 0.75 alpha. And this is from kinematics analysis. Okay, we found this relationship, so I'm not going to repeat this. So we know that AGX is equal to minus 0.75 alpha. So coming back to here, minus 0.75 alpha. So you get minus 150 is equal to 22.5 multiplied by minus 0.75 alpha minus by 5.625 alpha. Okay. So this you will get minus 150 will be equal to 22.5 times by 0.75 plus by 5.625. So this is equal to minus 22.5 alpha. Okay. So this relationship, I call it our equation A. Okay. If we see what we done yesterday, I'm going to superpose or put what we have done. If we have done this, I'm going to copy what we have done on Monday. Right. So on Monday, what we did, okay, you don't need to do this, okay? I'll do it for you. We took moment at G, right? We took moment at G, which is different from what we have done. Don't copy this, okay? I'm going to do this for your convenience. Then from there, we have this relationship over here. Okay. We have built a relationship over here, right? So you can see how different the equation appeared. And then a bit fast forward, we have formed this equation in terms of AX, right? So we had this relationship, right? So it is still not the same yet, right? Then we found what is our AX. Okay, so we found this relationship where AX is equal to what? AX is equal to, okay, this expression over here. And finally, what we had yesterday is we also conclude with this relationship. Over here, which is exactly the same. Can you see the final form? Okay, can you see this equation over here? I'm going to highlight. Right, this equation and this equation, the relationship is exactly the what? The same. Yes or no? Where's the gentleman that asked me this question yesterday? Oh, okay. It's on the video. Okay, are we clear? Okay, so again, be very comfortable. Any way you take is fine. Okay, what is most important thing is this. Okay, what is the most important? I think it's also the same for 2P. We know that there's a moment acting at this point, yes or no? Right? If I pick the point over here, wrong color. If I pick the point over here, does it see the 150 Newton meter? Yes or no? The answer is yes. If I pick a point over here, it will still see the what? 150 Newton meter. If I pick the point here, does it see the 150 Newton meter? The answer is what? Yes. Are we clear? So Dr. Koshi, are you all learning shear force and bending moment diagram, or you guys are done with that? Right? Is it clear, right? If you have a moment, regardless of where the moment is acting on, the moment, it has to be considered. Same for 2P, should not be any different for what? 2Q. Are we clear? Where are you all in 2P now? Eh? Oh, eccentric loading. Compensate material. Okay, okay. Good stuff. Okay. Right. So that's what I want to clarify first. Second, I'm going to continue on this example. Okay. So again, what we have done, let's review this problem very, very quickly. So what we have, the beam is 500 pounds. is supported at A and B and is subjected to a force 1,000 pounds, okay, as shown. If the pin at A suddenly fail means all the reaction forces will disappear. Determine the beam's initial angular acceleration and the force of the roller of the beam. And then for the calculation, we're going to assume that the beam is a slender bar so that the thickness, it highlight over here, that the thickness can be what? Come on, Eugene, seriously? That the thickness can be neglected. In the exam, maybe I can tell you that the thickness cannot be neglected and I give you a certain what? Thickness. Okay? Even if I will give you a certain thickness, there's only going to be an extra moment. Are we clear? Okay, let's say if a certain thickness is given, let's say if this thickness is known, right? The only thing you have to consider now that's different is over here, which you get what? This is your 4/5 multiplied by 1,000. This over here will generate a what? A moment. Are we clear? Okay, right? So the moment equation will change slightly. You only have an extra what? Moment vector coming. Are we clear? Nothing difficult. Okay. Now, so what we did, so for this case, we are going to assume that the thickness can be neglected. We do summation of forces in the X, and we have a value of 51.52 feet per second squared. Okay, so that's the acceleration in the X direction. We do summation about forces in the Y. Okay. Then now we do the moment Z at point A. Now let me show you, okay, let me show you, okay, in case you guys are worried. It's like, Eugene, you tell us to do something, then you don't show an example. So now let's consider if or when the thickness of the beam, or not, don't call it thickness, come on, Eugene, the height of the beam is 2 inches. Okay. And okay, make it 10 inches. Okay, because it's in feet, 2 inches count, mediocre. Okay, it's 10 inches. So when we do that, okay, so watch this. Okay, we're going to do summation about moment Z at point A. And this is equal to summation moment Z at point A in the kinetic form. Okay, so the 3/5, right, will still be the same. Okay. So now what we have to consider, so now everything is in feet, right? So 1 feet, so side work, I'm going to put down here side work. 1 feet, how many inches? 12 inches. Okay, so side work is 1 feet here. So now if we were to consider the 4/5, and the 4/5 will also generate anti-clockwise direction. So this will be plus by 4/5 multiplied by 1,000. And the height is what? The height is 10/12. And then the next thing is plus by 500 multiplied by 5 minus by 2by, and then is equal to 15.528 AGY multiplied by 5 plus by IG alpha. The only extra term to come in is over here. Are we clear? Nothing difficult. Straightforward. Later on, when you do 3A, a lot of times this has to be considered a thickness. Yes, sir. Say it again. It's exactly at the center. Exactly. The center of gravity is always at the center. Are we clear? You okay? Or you have a question for me? Okay, good. Okay, so let me repeat its question. The weight of the structure is always at where? Acting at the center of what? Gravity. Are we clear? Okay, so that's why there's no extra moment. Okay, so this is just an extra thing. Okay, so we are from here. I don't want to confuse you. Okay, we are going back to the question. Yes, ma'am. Yes. Yeah, that's why 500 multiplied by 5. This 5, right? Is that what you're referring to or no?